Welcome back. So, in the last lecture, we talked about the difference between what color temperature is and correlated color temperature is. Okay. So, one thing I think you have all understood is that color temperature is something which can be mathematically be very intensive in nature. It involves a lot of calculations, etc. But for all practical purposes, in order to find out the color temperature of all illuminants or any other object for that matter, we refer to not the color temperature but the correlated color temperature. It is a much more easier method of computing the color temperature. So the only difference, okay. So just as a method to recap from the previous lecture, that this line, this curve, sorry, this curve is known as the Planckian locus, right? This has been obtained by joining all the points, all the color temperature for all the colors that are available to the human eye. So together, when they have been joined, we have obtained what is known as the Planckian locus, right? Now we draw some lines on top of the Planckian locus. So actually, the work was originally done using UCS, or the uniform chromaticity space, which has certain advantages, whereas this particular XY chromaticity diagram does not have those advantages. So by now you know what those advantages and disadvantages are. Now, one thing that if you can just go back to the previous lecture, if you can recall that the isotherms, these lines are known as isotherms. So these isotherms in UCS were perpendicular, right? I think I mentioned it, that these isotherms are were perpendicular to the Planckian locus, right? But as you can see in the XY chromaticity coordinate space, these isotherms are no longer perpendicular. So this is again, this has been projected from the UCS, and when they were projected into the XY, it didn't turn out to be perpendicular. So that is not something which you need to worry about. But I asked a question in the previous lecture. I will not give the answer to that question, but I gave you a practical problem. That is, you see, this color, or this end has got a color which is, let us say, a reddish or grayish. Maybe a light violet or something like that, and this color is actually green in nature. But I said that all the colors along this line will have the same color temperature, that is 6000 Kelvin. All the colors along this line will have the same temperature, 10,000. So similarly, likewise for everything else. So I asked you, although this has got some real life problems, but I asked you what is going to happen if I am going to extend this line further. That is the question I asked. So I need to hear answers from your side regarding this particular problem. What problem would I have faced, or the industry would have faced, if these boundary conditions for these lines, these isotherms, were not mentioned or not scientifically determined? So that has to be coming from your side. I will not give the answer to the question. So you need to figure it out on your own. Okay. So this is what color temperature and correlated color temperatures are. Now, next I think we will have. I think this is a picture that you might have seen in various social media platforms. This is the same dress. So again, we have now shifted from color temperature to another concept related to color difference. You remember while talking about color temperature, I talked about distance between two colors. I showed you the formula to calculate the Euclidean distance between the two colors. So keep that in mind before we begin this. Okay. So take a look at this picture. The three dresses are there. Okay, 1, 2, 3. Now I think for those who have already seen this image in the social media, you know by now that these dresses are actually the same dress. This is the same dress under different lighting condition. Okay, so this is the same. The three pictures are of the same dress but of different colors. So the question is that whether this dress is yellow or this dress is blue. Okay, that is something that you need to figure out on your own, but I am asking you to observe this. What do you observe? that the color of the same material is varying under different light or illuminate conditions. Now go back to when we were discussing those tri-stimulus value. What was the formula in order to find x, y and z? It was lambda equal to 400 to 700 x bar lambda into L lambda into O lambda d lambda, right? So what is x bar? Y bar